Welcome back to this second part of this tutorial on vents and FDS and BFDS. So in the first video we have already posted, we've been talking about how to create a fire using a vent and how to create an opening in our domain so the smoke can get out of the domain. In this second video and final part of the vent tutorial, we are gonna see how we can use vent to create a ventilation system inside our domain. So we're gonna focus on AC unit and work together the steps required to create this ventilation system in our domain. Let's go and have a look at it. So the first things that we need to do is to remove this first vent, burner, and remove all the parts that we have already had in this scenario, because we are gonna use this domain with this opening here. So the first things that we need to create an object that simulate the geometry sides of a heat pump. I'm gonna press Shift A, then I'm gonna have a new cube, and in this case I'm gonna change the dimension in a second step. I want basically to leave it as it is in this case and see how we can reshape it and move it around. So let's select it, and this is gonna be AC object. Then we need to go to items and resize it. So on the zeta direction is gonna be for me 0.2. On the y direction we can make it 1.2, and on the x direction can be another 0.2. Fairly small unit. It's there, and we need just to locate it somewhere here. I'm gonna quickly try to figure it out how, by play around with the location by moving it on the x direction. 1.9 should do the job with a beautiful minus behind, and then we need to shift it up to put it 2.5 meter. It seems that the location is fine. It's still not an FDS object, so we need to go and change his property. It's gonna be a OBST, of course, and we need to not have any surface, but we need to go to XB and select boundary boxes because it's a simple geometry. So geometry is doing the work. Now we need to create new vent. So if you want to have an easier job, in this case we are gonna not create a plane from scratch. We are gonna learn how to create a vent starting from the faces of this element here and modify from it. So let's go and have a look how. So the first things we need to do here is to go to edit mode. Then we need to press select faces. Now you can see that I've selected the faces. Now we need to press Shift D, select again, Shift D, and you can see that now we have a new item that can be located. But of course we don't want to do any crazy location. If we want to just make sure that it's just moving around towards the X axis, we just press X. You'll see that now it's just blocked on the X, and if we do it with Y, it's gonna be moving only with Y, and same with zeta. And we can just press 0 to locate it there. Then another tab that we need to press is P and selection. So now we have been creating a new element that is a plane exactly the same dimension of our starting faces of this cube here. So we can go here and rename it. We are gonna call it vent out. We can rescale it a bit. I don't want it the same size of this face here. I'm gonna make it a bit smaller. So something that we need to do is to go back to the original object mode. We were in the edit mode. You just click here. So now we go and select vent out, and you will have the possibility to rescale it and change even the location. So you can see on the Y it's 1.2. I'm gonna put it only 1, and I'm gonna rescale it here 0.1. So we're gonna have a vent that is 10 centimeter by 1 meter. So let's go and change the property of this vent. So let's go to select vent, go here in the property. We're gonna select, of course, vent out. In this case we are gonna create a new surface with a specific property, and as we have done before, we need to go to XB and select faces. So now that this is done, we can go and create the new surface for this vent that is gonna basically suck air from the domain. So let's go and change the material property. Let's call it this surf out. So it's basically reminding us that this vent is gonna catch air from the domain. So to do it, we need to add a property here. We go on plus, we type vel equal, and then we specify how many meter per second the flow is gonna go through this vent to get out of the domain. So let's put something relatively small, 3 meter per second. And now let's go and create the second vent that is gonna instead pump hot air into the environment. So let's go and have a look how. I want that the vent is gonna operate somewhere here, and I want to make sure that the heat goes down here. So to do the trick, we need to do exactly what we have done before. So we need to select the object that represents our IC unit. It's here. Then we go to edit mode. We select the surface at the bottom. And as before, Shift D, and we are duplicating it. Now we are gonna press zeta so we can move it only on the zeta axis, and we want to press 0 because we want it attached to the object, and press P and selection. So you can see that the new object has been created and it's gonna be the new vent. We need to go back now to object mode. So the other element, it was vent out. So in this case, we are gonna call this element vent in. So let's select it, go to the FDS property and change quickly the property to vent. So this is the vent in, and we need to check again XB faces and go to the material where we are gonna have new material. So in this case, we can call it surf in and start defining the property right here. So in this case, we can go right here, click, and once again, we are gonna put velocity equal. Let's put the same size, the same dimension, so we can have the same amount of air getting in and out. The only things that we forgot to do is to rescale this object here. In fact, it's gonna be slightly bigger than the other vent that is pumping air out of the domain. So let's do the same adjustment that we did for the other vent. Play around with the scale. So this should be 1 and this one should be 0.1. So we still have same dimension of a vent of 10 centimeter by 1 meter. So if we put the same velocity here, we will have the same amount of flow getting inside of the domain. So in this case, nothing's gonna change in the temperature. We need to add a new parameter. The parameter that we are adding here is temperature on the front. We are gonna select something relatively cool. Let's put actually something really cool, 10 degrees. And the domain, if I'm not wrong, as a default setting is gonna be 20 degrees. So we will definitely see a change in temperature into the space, not just the change in the flow. So now we have temperature 10, and we are pretty close to complete this scenario. We need actually to check that the surface associated to this vent are correct. So let's go and see vent in. You can see that we need to press surface, and surface in is what we want. Vent out, we need to press surface ID. It has been selected the surface that it was already in this tab. So vent in and vent out. The other things that we can do potentially is also to change the color. This is relatively easy to do. So for vent in, we can put a blue vent, and instead for vent out, we can put just a nice pink color. So let's go and have a look how this is reflecting in the FDS simulation. So let's run it. You can see that we still have a running simulation, so you can be pleased with it. Let's open Smoke View and see what is the impact of these vents on the full domain. So you can see that the visualization is not bad, and probably this vent has been rescaled because it's not really matching the mesh sides. So that's something that we need to readjust probably later on. But let's see if the results is affecting the domain. So I'm gonna use a slice of temperature and see what's going on. So it seems that the scenario is not running as intended, and probably it's because we need to slightly shift to make sure that between alignment with the vents and our FDS mesh domain. So I'm gonna try to move things a bit around to make sure that we have a good alignment. I finally managed to spot the mistake. In this velocity, we need to put a -3 so we can start pumping air into the domain and see something finally happening. That's the problem with FDS. If you change even a sign, it can be a dramatic change of all the simulation. So let's run it again. In the previous version, we just had two vents that were sucking air from the domain. In this case, we are gonna have one pumping air at 10 degrees inside the domain. Let's go and see in opens on smoke view. The shifting of the vents slightly of 5 centimeters really helped in aligning with the previous mesh that we defined for this simulation. So let's go and open a slice for the temperature. And there we are, the AC unit is finally working. I just adjust this -3 here. You can see that now we are capable to pump cold air inside the domain, and you can see the impact of the full simulation. If you want to slow down in case this is too fast for you, as always, you can do it by going to option, max frame rate, try to run for time real time. You're gonna get much smoother way to visualize, and you can see that the cold air pumped at 10 degrees gets down because of the temperature, because of the floor is directed towards downwards. You can even see the impact of the opening of the full domain. If we want to see even the vectors, we can go to loads and vector slice. In this case, I'm gonna visualize also the velocity. You can see the flow rate is going downwards and then moving towards the opening. So we have successfully created our first AC unit. Well done to us. So this is another example that I created a few days ago. And in this case, I wanted to have a floor that change with time. So the direction of the floor is not gonna be constant towards downwards or sidewards. It's gonna change basically on time. So how did you achieve it? You can see here we still have a vent that is catching air out of the domain, and here we have two vents that are pumping air inside the domain. And by a combined effect of these two vents, I managed to have this floor jet that change direction based on time. So you can see that vent 1 and vent 2 here, they are still vents. And the trick is done here. You can see I created two material. We have a vent 1 that has material 1 and vent 2 that has material 2. You can see that the property are slightly different. You can see that the velocity is -12 for both of them. The front temperature is 15 degrees for both of them, but I assign two different ramps. So you can see here ramp Z and ramp X. And if we go expand here, this is a ramp code that I generated once again with AI, and stay tuned because there are more AI video coming up on application in many other aspects of civil engineering and fire protection engineering. So you want to stay in touch with this channel once again. And you can see here that this vent is basically increasing and decreasing the flow of the velocity of these vents. So you can have a combined effect and have a jet that change direction. And in this case, we don't need to run the simulation because I've already done a few days ago. So let's go and open it in smoke view and have a look at the results. This is the scenario in smoke view. Let's go and see a slice of temperature. So you can see that the flow of cold air is changing with time and is basically doing what I was expecting, having a dynamic IC unit with a jet that is changing direction, just using a bit of original thinking and some ramps and vents. So pretty cool, huh? So in this video, we discovered the beauty of BFDS and one of the most powerful elements in FDS that are vents. We use it to simulate a fire, we use it to have an opening in the domain, and we use it also to create heat pump or AC unit. So really good stuff to have in your knowledge suitcase. So the next video are gonna be more about AI and how AI can be integrated in your workflow for fire protection engineering or civil engineering. If you wanna know more, I've already put a recording right here in this video in which I've been talking over an hour about all the possible way to customize AI tools and have your own personal GPTs or personal agents that help you in your workflow. So you don't really want to miss this video. See you to the next episode and bye from now.